So here I've got a sample problem, and I've got two bijective functions and I need to find their inverses. So in order to do that, we could of course use the method from the very first slide and just think about how these functions would work in reverse. But that's not really the easiest method, and it's not the most convenient. So I want to introduce a new method that we can use in order to find inverses without really having to think about what's going on too much. And it's going to involve rearranging these formulas to make the input variable x the subject of the formula. So I'll start by finding the inverse of g. So I'm just going to rewrite out g of x, but I'm going to use the y equals 2 notation, just because it will be neater to rearrange then. So y equals 4x minus 8, and I need to make x the subject of the formula, which just means I want x on its own on the left-hand side. So the first step there might be to bring over the minus 8 to the left-hand side. So y plus 8 equals 4x. And then the last step would just be to divide both sides by 4. So x equals y plus 8 divided by 4, which is just y over 4 plus 2. So now I have x in terms of y. But for my inverse function, for g inverse, I don't want y to be my input variable, I want x to be. So I just need to relabel this. So instead of having x here, I want to have g inverse x. And instead of having y as my independent variable, I want x to be my independent variable, or my input variable. So I'll have x over 4 plus 2. And that's g inverse. So I'm going to do the exact same thing for my cubic function h to find its inverse. So I'll use the y equals 2 notation again. Y equals 5x cubed minus 1, and I need to get x on its own on the left-hand side. So I'll bring over the minus 1 first. Y plus 1 equals 5x cubed. Then now I might divide both sides by 5. So y plus 1 divided by 5 is x cubed. And then to get x on its own, now I am going to get the cubed root of both sides to get rid of this cubed here. So x equals the cubed root of y plus 1 over 5. Remember, we're not finished though until we relabel this to make x our input variable. So we need to replace this x here with h inverse of our input x, and then on the right hand side here, instead of y, we have x. So x plus 1 over 5, and that's h inverse.